All right, so guys, I wanted to make I just want to record this introduction to standard deviation so that people can kind of go back and see some of the keyboard shortcuts that you might need to make your graph. And then actually, because people were kind of struggling with this the other day, to make the graph, the really specific graph, when you're going to take this piece about standard deviation and add it to your graph, I'm going to show you what mine would look like for heart rate, and then you're going to try that with breathing rate if you want. I can't make you try it, but at least hopefully you'll have this reference so that you can understand what the expectation is to be able to do with this. So just to show you what we're trying to do with standard deviation is we're trying to see where most of the data points are. So, what most people probably started out with was some kind of it might have been a bar graph, or it might have been just a point that you plotted. But we talked about, the independent variable being the activity level, and then having these different whatever you call the activities level: rest, light, moderate, intense. And then this is, for heart rate, plotting these averages of all the people, right? And so we talked about how to do that. Should have been something that people knew how to do, right? An average, which really is a mean. And so actually, one second, let me close this. Nope, I don't know where that other one is, but so this is my average, and then you might want to just select, like, I want these data points. And then this is my average here, right? So I plotted that right at 73. And you can do that for the other heart rates as well. So if I just look at the average, and so if you ignore these error bars for now, like you can see, it looks like heart rate increases for every level of activity, right? Like the average is greater. But what we want to be able to do is say, are averages significantly different? And what we're going to see is that for moderate and intense exercise, they had different averages, but because of the variance or the variability between different people's heart rates, ultimately we're going to say there isn't a significant difference between moderate and intense exercise. So what we're going to do first is kind of focus in on just this rest, this heart rate. And again, so the average is 73, but what we want to find out is how do we show in the graph, without plotting everyone's data point, where most of the values for that heart rate were. And so that's where there's some different ways you can do this. And actually, I'll show you, some people might know a little bit about the range, right? So you could just look through these data points. You could just say, who has the lowest heart rate? And I think it was this 60 here. And then there's somebody, like the highest heart rate is 85. So these red error bars, it's one way of saying where we're, what was the spread of all the individual data points around the average, right? So you can say, so these red error bars, we're going to say that's the range. It goes from the lowest data point to the highest data point, and then we've, again, shown the average as what we plotted. Okay, so what we're going to do here, and I'm actually going to show, because somebody in one of the classes asked, how do you calculate standard deviation? And Dr. Sheridan today told me that you have actually probably done this before. So I think she said in integrated one, people calculate standard deviation. So since it appears as though some people have done this, even if you don't remember, I wanted to just show you, what does that look like? And so also I just typed this into Google to get the formula. But this is interesting too, just to think what is standard deviation, right? It's a measure of the amount of variation or dispersion of a set of values, right? So here's our set of values, and we want to know what's the variation. We know the mean, but how much do those individual data points vary around the mean? So the formula here, and this is actually, you're going to see there's two different formulas, and actually you can see them here. There's one for a sample, and there's one for a population. We took a sample of 16 to 17-year-olds, and so we're going to consider this to be a sample. And the difference here is that at the end of it all, we're going to divide by the total number of people that we had minus 1. But so, and you guys can speed this up or slow this down, but I want to show you what actually are we looking at when we're looking at this variation of all the individual data points from the mean. And so this is every single data point, what's the difference from the mean? And so I can actually do this really easily with, right, I can say, what's the difference between that individual data point and the mean for these is 73. I'm just going to type this in. Google has read my mind. Yes, I want to do that. And then we're going to take that difference and square that, right? So the difference from the mean, we're going to square every single one of these. So I'm going to say this multiplied by itself. And they've done that again, right? This is each number multiplied by itself. Then I'm going to add all those together. So this is going to be the sum of these differences from the mean squared. Then I'm going to take that sum and divide by, but again, here's where I'm going to do the number of the population minus, or sorry, the number of the sample minus 1. So I'm going to take this number divided by the total number of data points is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14. 14 minus 1 is 13. So take that. And then I'm going to take the square root, and I'm sure there's a formula for this, square root of this. Right, so just to show you what that is, right, there is a formula, you can do this, but what you mostly have to do is understand what it is. But you can kind of see, right, it's a representation of how far are all of these individual data points away from the mean. So the faster way to do this is to say, right, I want to figure out what's the standard deviation, and you're just going to, again, select the value. So I want to know what's the standard deviation of all these values. And it's interesting, it's slightly different here. I'm not entirely sure why that is, but it's very, very close, right? And realistically, you know, when we're talking about plotting numbers like 73, and we don't really have to worry about the 7.1, right? So our heart rates, we were recording to a precision of one beat, right? Because we know that there's some uncertainty in those measurements. And so this is going to be our standard deviation. So when you're going to plot this, and here's where you can see this is what my graph looks like. You know, so for rest, and actually hopefully you guys can see this. Oops. Let's see that one. So a little bit closer, right? You can see that. So my blue error bars, right? The average is 73, and then the value of the error bar is the standard deviation, right? And so there's this representation, I think it's like 68% of your values are contained within one standard deviation above the mean and one standard deviation below the mean. You can also, people plot different things for error bars that show variance. So there's standard error of the mean, all these different things. But you can also, you could plot 2 standard deviations, and that would contain, I think it's like 98% of your data points. So notice that, you know, if we look at this range, so again, like 73 plus 7, so up to 80, 73 minus 7. So actually this, I think when I originally did this, it had rounded, like I had done something like this. So I did like upper error bar, and then I did lower error bar, and I just did this a lot faster. So I did, you know, what's 73 plus, and I just copied these formulas so that I wouldn't have to do this every time. But, and then 73 minus the standard deviation. And so this had rounded. So it showed me that, you know, 68% of my data points should be within this range. So, so hopefully that shows you how to do this, and you can check, right? You can go through and for the heart rates, again, my graph is only heart rates. You know, you can do the average, you can calculate the standard deviation with the formula, right? And this is the mean. So, but the important part here, so this is what, if you still want to try this and see if you can do this correctly, you might want to try to do this with the breathing rates. But notice that what we're going to do is say that if these error bars of 2 values don't overlap, right? And so you can see this here, that, you know, the top limit to rest is below the bottom limit for light activity. And I'm looking at the standard deviation error bars. We can say there were significantly different heart rates for rest and light activity because these error bars don't overlap. And, you know, we can say there's significantly different heart rates for light activity, which was walking, and moderate activity, which was, I forget, but jumping jacks. But notice right here is where you can say there's not a significant difference between heart rate at moderate and intense activity level, because if you look at kind of the ranges here, so first of all, we didn't have as many data points, But we had some people that were, what was the highest? 164? Yeah, interestingly, yeah. So 164 was um, the highest point that we had. We had somebody down around 100. And so, based on those, we just say, like, these aren't significantly different. If we had more data points, perhaps we would see that they are. And then the thing that we're going to do with like people that kind of want a challenge, we're going to take a look at another statistical test that even with overlapping error bars might be able to tell us that averages are significantly different. So that's kind of our next step. But everybody should be able to do this, kind of understand what standard deviation is, right? How it relates to your individual data points. You don't need to know how to calculate it, even though maybe you've done that before. But really, understanding what it is and then understanding how we use it to say whether averages are significantly different. So here we could say, heart rate goes up with increasing levels of activity, but it doesn't increase significantly when you go from, in this case, jumping jacks to squat jumps from the data that we had.